0 fiber, 137 calories, 13 grams carbohydrate, 9.7 gram protein, and 4.9 gram fat. So these are nothing but the technical specification. How do you get the technical specification? Based on the customer requirement. Customer expects all this. So you built a product, right? And now there are 5 characteristics here. Please note, each of the characteristics is called CTQ. CTQ means critical to quality. If you get all these values exactly like what is written, then the quality is at its best. Whatever you committed, you are actually offering to your customer. That is the best quality. And each one is called CTQ. Please note, sigma level or the capability is measured CTQ wise. How many CTQs are here? 5 CTQ. Each of the CTQ, if it fails, customer is going to reject your product. For example, calories are not as per the spec, customer will reject. Carbohydrates are not as per the spec, then also product will reject. So all the 5 are important. So I am going to take 1 out of the 5. Let us say the calories. The customer requirement is 137. Customer requirement is a pack of 100 ml milk should have 137 calories in it. Do you think you can produce milk 100 ml with exactly 137 calories in all the milk bottle? Is it possible?
No.
Very difficult, right? So there will be some tolerance. Customer knows that. Customer gives a tolerance. See here, 137 plus or minus 2. 137 plus or minus 2. Now tell me, what is the USL here? 137 plus or minus 2. What is upper specification limit?
139.
Very good. And the lower specification limit will be 135. Now your job is to run a milk factory which will produce milk bottles, and each of the milk bottle should have calories between 135 and 139. If that happens, the milk bottle will be accepted. If that is not going to happen, the milk bottle will be rejected. Sometimes based on a sample, the whole lot of milk bottles you produced might be rejected and sent back to your factory, right? So the ability of a business process to meet the customer's requirements is called capability. And that capability is measured in terms of sigma level, right? And not just once or twice, but whatever units you produce, everything should be within the spec. That is called the capability, right? And now I have visualized the discussion. See here. Customer targeted value is 137 calories is the customer targeted value in each milk bottle. And USL is 139, LSL is 135. So specification width is 4 calories. How do I get it? USL minus LSL. It's clear. And now I want to know whether my factory producing milk bottles is really capable of meeting the requirement or not. Now, some of you can now tell me, if you want to check whether your factory producing milk bottles is capable or not, how will you check the milk bottle? Will you check each and every milk bottle, or you only check some samples?
Samples.
You will only check samples, and that is where the knowledge of normal distribution comes into picture. Because if you take a sample in the right way, you know there should not be any sampling error, there should not be any measurement error. Then whatever characteristics you observe in the sample will reflect the population characteristics. A sample of 10 milk bottles or 100 milk bottles, how it behaves, based on that, you can judge on the thousands of milk bottles which you are producing from your factory in every single shift, isn't it? So I am going to study a sample of milk bottle. Yeah, any question here?
So, Shivkumar sir, question is, for example, you're talking about sample. I don't know, we might be covering this in further topics. Any sample statistically that has to be taken, any standardization is there?
Yes. Yes, we will be talking about the sampling. Definitely, sample selection is very important. When you take sometimes sample, if the sample is inadequate in terms of numbers, then you may judge wrongly on the population. That will lead to errors in your decision. You may wrongly reject the product produced produced in a factory. Sometimes you may wrongly accept the products produced in a factory based on inadequacy in the sample. Another thing is sampling technique. How do you select the sample? Is that you just go randomly on a particular day and take the sample, or you go every single hour and collect the sample? How do you select the sample? That is also important. So that will be taught to you in measure phase. Sample size
Got it.
as well as sampling technique. Only if you keep the sample size and sampling technique right, then the sample will speak the reality. Otherwise, it will mislead you. Very good question. All right. Now let us not worry about the sampling technique and other things. Let us assume our samples are perfect. Let us say I have taken 100 samples. That means 100 milk bottles I have taken. Now what do I do with the 100 data? 100 milk bottles are there in my hand. I'll send all the 100 to a laboratory. The laboratory will check the calories that is present in each of the milk bottle. Since 100 is the sample size, how many readings I will get? 100 readings I will get. What will I do with the 100 reading? First thing I will do is I will calculate average. See here, the average calculated from the sample is X bar. How to get the X bar? Add all the 100, divide by 100. Here, you are able to see 137 as the average. Customer was expecting 137 calories in each milk bottle, and your average is also 137. Is it good for your business? Yes. Definitely good, right? Definitely good. Getting the average on the target, that means your process is centered perfectly. Your process is centered on the target. Target is 137, and you have centered the process on the target. That's a beautiful scenario. Very good. Since average is 137, does it mean all the milk bottles that is coming out of your factory has exactly 137 calories?
No.
No. Definitely no. Right? Only the average is 137. However, each milk bottle may have its own value. You wanted to understand how far each milk bottle is deviated from the average. For that purpose, you must calculate standard deviation. Sigma equal to 0.66. I have simplified the job for you. I calculated myself. But what is the formula to calculate sigma? Square root of summation of x minus x bar the whole square divided by
n minus 1.
N minus 1. Very good. You know everything. X bar is known and n is equal to 100, and so sigma equal to 0.66. Once you know average and sigma, you will be able to locate control limits. Am I correct? Yes. Upper control limit formula is x bar plus 3 sigma. X bar is how much? 137. Sigma 0.66 means 3 sigma will be how much? 0.66 into 3 will be 2. So 137 plus 2, 139 is your upper control limit. Am I correct?
Yes.
Very good. Same way, lower control limit will be 135. Lower control limit is 135, upper control limit is 139. Now you want to understand your process capability. If I run the factory in this fashion, how much will be accepted by the customer? How much might get rejected? I have set everything. This is my capability. How do I know? I have run a trial run. I have taken the sample, and sample is spreaded like this, and I could see a kind of a bell shape and all those things. Now, in order to understand the capability, I will overlap the process width with the specification width. See here, I have overlapped. Specification width is 4 calories. Process width also 4 calories. Now, what can you comment about the process? See here, control limit, upper control limit overlap with upper specification limit, and lower control limit overlap with the lower specification limit. Now the conclusion is 99.73% of the milk bottles are inside the specification limit. Can you say like that?
Yes.
99. Yeah. Where from I get this number 99.73? From the from the knowledge of normal distribution. According to normal distribution, it is very clear that 99.73% of your points will lie inside control limit. And my control limit is touching specification limit. So the 99.73% of the milk bottles will be inside the specification. Imagine you produce 1000 milk bottles. Now how many milk bottles will be inside the spec? According to the sample you have studied.
997.
Very good. 997. Very good. 997 milk bottles will be inside the spec. Customer will be happily buying the 997. So how many milk bottles will get rejected? 3 milk bottles will get rejected. Are you now happy with your business?
No. No.
Why no? 997 milk bottles you are getting paid. Only 3 bottles are rejected.
Yes,
So
sir.
this situation is equal to the earlier example that you have shown is elephant and top. Both are unequal. Then there should
Correct.
it's difficult.
Correct. So it looks like 997 out of 1000 is getting accepted. But generally, what happen in a longer term when you continue running the factory, and then produce more, there are other challenges will come into play. The raw material quality, the machine setting, the operator changes. There are many things will happen. So your capability of 99.73% is expected to fall down, and the damages will be much more and rejections will be much more. So 99.73, whatever capability you have seen now, is only your short-term capability. Always the long-term capability will be lower than the short-term capability. As a true business leader, you are concerned about your long-term capability and not just on the short-term. These data you have taken just over 1 day or 2 days, isn't it? But you are going to run the factory and produce over a longer period. So long-term capability is important. And looking at the long-term perspective, the 99.73 is not good. 99.73 can drop down to 90, can drop down to 85. And so rejections, can keep on increasing. And that's why, you are not happy with the 99.73. Otherwise, this is okay. So this process I will consider as an elephant process. You know why? It is a big animal. And, since the control limit has come to the extent of touching the specification limit, you need to understand that you put a big animal, elephant, in a small room. The elephant is fully accommodated in that small room. And do you think the elephant will stand very calm in a small place? Definitely no. It should be given some moving around space, which is not there. So as a result, as the elephant moves left or right, then the control limit will go beyond the specification limit, the rejection will happen. The elephant is nothing but your business process. Your business process also is prone to deviations. You can't expect the business process central tendency to stay always on the target. The central tendency itself can shift to the right or can shift to the left. The process spread, what you are seeing here, it is spreaded up to control limit. This process spread also can increase. If this process spread increases, control limit will stretch further. If the control limit stretch further, you see the portion of the curve will also get extended. That means the rejections will be more. See here, considering the best scenario, the control limit falling in just exactly on the specification limit. Right now, the rejections are only here. So these rejections are found to be 0.27, which is okay, tolerable as of now. But in the long run, what will happen? The process itself is shifting. This is called process shifting. Is there a possibility your entire process can shift? Possible or not?
Yes.
Process average, instead of staying at 1.7.
Possible.
Yeah, possible. As the process center shift, and your control limit will also split, will also move away. And now you see a major portion of the curve or major portion of the point under the curve are beyond the specification limit. So 8 to 10% of the milk bottles which you are producing might get rejected in the long run. Why? In the long run, central tendency may get shifted or control limit can get shifted. So both ways your process can deteriorate and make the damages to increase. So looking at the long term, the capability of 99.73 is unacceptable. Though it looks close to 100 in a short term, in a long term, we will experience a rejection of 8 to 10%. That is why we need higher capability. And now coming to the statistical part of it. This process is called just capable. This process is called what? A just capable process. Why it is called a just capable? See here, the control limit, the specification, right? And now tell me, when the control limit is overlapping with the specification limit, what is the distance between the process center and the nearest specification limit? Center is here, nearest specification limit is here. How much is this distance?
1 sigma.
3 sigma. So you call the process as just a capable process or a 3 sigma process. Sigma process means the yield is 99.73. That means success rate is 99.73. However, this 99.73 success rate is applicable only for short term. In long term, the 99.73 will fall down. Is that clear to all of you?
Yes, sir.
Right? So this is 3 sigma process. Why the capability is going down? If the control limit deteriorates or the process center deteriorates, both can lead to problems. Right? So that is why we are looking at higher capability. So how do you gain the capability? By controlling the two parameters. One is central tendency, other one is variation. Look here, our central tendency is on the target, so we don't see any problem. But in the previous case, what was our standard deviation? 0.66. Now I do some changes in the process. Maybe I maybe train my people and then make some arrangements to ensure the standard deviation is reduced. See here, now the standard deviation is 0.33. How this reducing standard deviation is going to be helpful for me? When you reduce the standard deviation to 0.33, what will be the revised control limit? 0.33 into 3 will be 1. So 137 plus 1 will be 138. What is 138? My upper control limit. Now, similarly, the lower control limit will be 136. But where are your specification limit? It's here. USL is 139, LSL is 135. Now, one of you tell me, what percentage of milk bottles will fall between 136 and 138? What percentage of milk bottles you produce will fall between 136 and 138? In terms
99.73.
99.70. If 99.70% of milk bottles can fall between 136 and 138, what percentage of milk bottles can fall between 135 and 139? Much better than 99.73, isn't it?
Yes.
That is found based on the normal distribution. Maybe you can ask Dr. RK and how these numbers are coming, right? 99.996% of the milk bottle will now fall inside 135 and 139. Now, if you are producing 1,000 milk bottles every single shift, right? What percentage of milk bottles will be accepted? 99.996. That means almost all 1,000 milk bottles will get accepted. All 1,000 out of 1,000 will be accepted because the rejection probability is very, very low. 0.0004 is the rejection possibility. You have reduced the probability of failure to a great extent. Almost everything you produce, customer will close his eyes and then buy everything. Tomorrow, you increase the plant capacity from 1,000 to 10,000. Customer increases the order because he is happy with your quality. He wants you to supply 10,000 milk bottle every single day. Even when the capacity is increased, demand is increased, still the 99.996% of 10,000 will make all 10,000 units accepted by the customer. This is how the number comes, 3.4 DPMO. When you produce 1 million milk bottles, then there will be a chance of 3.4 in some of the milk bottles, right? And this is how the capability increases actually. So this process, we can call it as giraffe process. You know why? We converted our process, which was earlier very wider, into a narrower one. And that will reflect in the center portion of the curve. You can see the curve taller in the center, which was not the case earlier, right? So that means you converted an elephant into a giraffe. But how did you know? By looking at the standard deviation. If the standard deviation is reduced to half, that means you have doubled your capability. And that's why the process is called doubly capable. And now the distance between the center of the process and the nearest specification limit. How much is this distance? Can one of you tell me? How much is this distance?
6 sigma.
See here, 3 sigma up to control limit and again another 3 sigma. So that means totally 6 sigma. So that's why we call the process as doubly capable, and you can statistically call this process as 6 sigma process. Customer has given you a tolerance of 4 calories, but your process makes use of only half of it. Only half of the tolerance is utilized by the process. Still the remaining half is will be available as cushion. Even if something goes wrong, process center is shifting or the control limit is shifting. At the maximum, the control limit will shift or the process will shift by a distance equal to 1.5 sigma only. This is a statistical prediction again. So how much distance your process has moved? See here, this distance will be equal to 1.5. Even after 1.5 sigma shift, your control limit will still be here only. See here, your center is moved, so control limit also moved. Still there is a cushion of 1.5 sigma. So literally, producing a defects is made impossible. And this is what we call it as, the Six Sigma capability of 99.996% yield. Right? So this area is beyond control limit. Though it is beyond control limit, only a small portion will customer find it as a problem, not everything. Because though the portion is beyond the control limit, still it is majority of it is inside the specification limit. That's how you achieve this magic number of 3.4 dpo, right? All right. So looking at this process, I'm just showing you a slide. Looking at the process, tell me what process it is. Is it an elephant process or a giraffe process?
Elephant process.
Elephant process.
It looks like a head of the elephant process. And statistically, what is the sigma level for this process?
3 sigma.
3 sigma. How do you say? The specification limit at
3
the
sigma.
center is equal to 3 sigma. So you have 3 sigma process. If the process is 3 sigma, what is the success rate or what will be the yield you can expect?
99.7.
99.73. But this 99.73, it's written here, 99.73 is valid only for short term. In long term, 99.73 will fall down. Now I convert that into another process, narrow. And now the control limit is pushed inside. Now looking at the graph, tell me, is it still an elephant or a giraffe?
Giraffe.
It's now a giraffe. And statistically, what is the sigma level now?
99.99.
99.996%. And sigma level 6 sigma. And the yield is, as you rightly said, 99.999% of products will be inside the specification. See, these are all only prediction. You need to understand. How are we predicting? With the help of 100 sample. We have taken 100 sample and we are talking about what is going to happen in our factory. We produce several million units. What will happen? How that thing happens. So, okay, sir, you wanted to add something here?
No, not now. No problem. I just wanted to tell about CP. No need. No,
not right. Yeah. So, if the amount of variation is too high, your data, that will reflect in your shape of the process. See here, it looks like an elephant. It looks like the head of the elephant. That is, it is wider. When the normal distribution curve is wider, you can understand under such situation, it is hard to produce output within customer requirement. Your sigma levels will be low, maybe 0 to 2. See, please note, 3 sigma level, the yield is 99.73. 2 sigma level, the yield will be 95%. 1 sigma level, the yield will be just 68%. So far, you might be, using the yield metrics, 68, 90, 95. You must be using it definitely. The same thing, we are expressing in a different style. We call it sigma level, right? 3 sigma means 99.73. 6 sigma means 99.999. 2 sigma means 95. 1 sigma means 68. So only that jargons are different. However, the meanings are same. So when the standard deviation is high, yield will be low, defects will be more, DPMO will also be high. On the other hand, if you reduce the standard deviation, your process will start becoming narrower and more taller in the center. If you see a taller process in the center with the narrower, that means the standard deviation is low. Virtually everything you produce will meet the customer requirement. That means your sigma level will be high. See here, we said this process sigma level is 6. When we discussed, we understood that process sigma level is 6. But when the process deteriorates, what is the assumption? It will shift by 1.5. So the 6 sigma process will eventually become a 4.5 sigma process in the long run. So for a Z score of 4.5, the failures will be limited to 3.4 dPMO. That is the statistical meaning. The 3.4 is actually found for a Z score of 4.5, not for a Z score of 6, because we look at the long-term capability. We don't want to settle with the short-term capability, right? So the capability of the value 99.996 is calculated using the Z score of 4.5. So wait for the learnings on Z score and the other things, which we will be teaching you in the analyze phase. So under such situation, the yield will be high, the DPMO will be low. Yes, sir.
Please note, sir, the same slide, the same slide. Participants, I want you to make sure that you have understood this concept very clearly, because jargons you should not get confused later on. I'm going to ask you a few questions. Kindly please answer you have understood or not, right? Okay. Now, standard deviation is a measure of variation. Am I right?
Yes.
Very good. And for the process to be very good, for the best process, the variation should be low. Am I right?
Yes.
Yes.
Therefore, sigma value should be low. Yes or no?
Yes.
Yes.
Good. Now,
Correct, sir.
for a process performance, for a best process performance, the performance level should be high. Yes or no?
Yes.
Yes, sir.
And the performance level is measured by sigma level. Yes or no?
Yes.
Yes.
Yeah. Yes, sir.
And therefore, the sigma level should be very high. Yes or no?
Yes.
Yes. Yes, sir, obviously.
Now tell me, the sigma value should be high or low?
Sigma value should be low.
Very good. And sigma level should be high.
High.
Please note, sigma value is not sigma level. Remember this.
Yes.
In your lifetime, you should remember that you should never make a mistake. Sigma level is denoted by letter Z. Z. Z, normally they call it. Z value should be high. Sigma value should be low. Keep that in mind. Thank you very much.
So sigma is standard deviation. Sigma level is your capability. So if you want your capability to be high, then sigma should be low. All right. So this is Six Sigma approach. A real-time problem, a milk factory problem is reduced to a problem with two numbers. What are the two numbers? One is X bar, another one is sigma. If the X bar is, where should be your X bar? Your X bar should be on the target. What is the target? 137 calories. Make sure the X bar is close to 137. That's the best way you can run your business process. If the X bar is close to 137, that's the best scenario. Then another metric you need to monitor is sigma. What should be your goal? Sigma should be as low as possible. But how will you reduce sigma? How will you move the center to the target? You have to see your process, real process. Look at your real process, and you need to control the inputs that goes into the process, the parameters of the process, to move to control the average and the standard deviation, right? So any real-time problem can be converted into statistical problem. A statistical problem, a statistical solution exists. The statistical solution is always process average on the target with lower standard deviation. The statistical solution is process average on the target with lower standard deviation. This is the solution. But how we make it happen? Then we need to work in real time. And now after this slide, if you have any business process, if you do any product, you manufacture any product, you offer any service, and we will help you identify the CTQ. We will also help you how the capability can be measured using what we learned so far. So the benefit is your organization's revenue will increase. Since you don't produce, literally you don't produce any defect, your revenue will increase, and ultimately the cost incurred in protection of defects will drastically go down. And as a result, your profit will increase, and the resource utilization will also increase. And ultimately, every project you do, there will be a learning. Your past project is your present learning, present knowledge. And the future project will decide your future learning and future knowledge, right? So doing Six Sigma projects will make the people very effective in the organization. If people are effective, automatically organization will become very effective. So a true leader will see to that the knowledge is provided to all the people, from top level till the down level, because they clearly know that the effective people can definitely produce the expected results. And individually also, these kind of skills will be very, very helpful. You will achieve the required leadership skills, nothing but problem solving and decision making. The leader is one who handles failure very effectively, the problems very effectively, right? So if you know how to systematically fix problems and then take decisions based on data, you will definitely be able to drive your people, guide your people in the right direction, and you will perfectly impact the business result, and there will be economical growth to the organization, and as well as that will reflect in your compensation also. And many people, I've seen many people they are able to generate the job offer which they wanted so far after becoming green belt or a black belt. And as a black belt, you will be definitely be able to work for a company which is in your dream, or if your company understands this and then implement, your company itself can become a dream company, right? So these things, if implemented, if understood and then implemented properly, will make you succeed in your professional life as well as personal life. I say personal life because all the learnings can be used in your to solve day-to-day problem also. It's not that Six Sigma is applicable only in your the industries. These are all philosophies: being customer focused, being process centric, being data driven, right? And fixing the problem at the root level. These are all philosophies you can apply everywhere. So Sigma level is a measure of process capability. Higher the Sigma level, higher will be the capability. 3 Sigma means your capability is 99.73. But it is short term. The limitation is short term. However, Six Sigma means it is 99.999%. The advantage is this is a long-term capability. Instead of using a G score of 6, we use G score of 4.5 and then derive the success rate, which is 99.999, right? And specification limits are the tolerance limits provided by the customer. Control limits are the tolerance limits calculated using process data. Whenever you want control limit, go to the place where you actually produce the product, collect samples. From the sample, you calculate the average and the standard deviation. Then you have your hand. If your control limits are well inside the specification, everything will be accepted by the customer. A 3 Sigma process is just capable. That means the short-term yield is 99.73. A 6 Sigma process is doubly capable. That means the long-term yield is 99.99966%. In 3 Sigma process, the control limit overlap with the specification limit. In a 6 Sigma process, the control limit will be moved towards the process center. You can see the control limit going towards the center. That will make your curve narrower. That will make your curve taller in the center. Higher the Sigma level, higher will be the capability. If you want Sigma level, standard deviation must be reduced, right? But how to reduce standard deviation? It depends on your process characteristics. So problem solving and decision makings are helpful in both personal life as well as professional. So that's it from me. Questions?